So what I'm going to talk about in this video is the specific things that we can use in relation to some of the functions that we defined so far in class. Now, to start with, we defined some things in relation to sine, cosine, tangent, secant, cosecant, and cotangent. But to go a little bit further, we just want to define these in terms of what we labeled them as. So sine was y over r, cosecant was r over y, cosine was x over r, secant was r over x, tangent was y over x, cotangent was x over y. Now what you should realize is that each one of these ratios is in relation to each other, the reciprocal. And this is, I can't spell reciprocal today. Each one of these is the reciprocal of the next one. So we can talk about these as the reciprocal identities. Now, in terms of a variable, the reciprocal is written as just flipping it around. So if we want to write something as a reciprocal, we can write it as just 1 over whatever the other thing is. So the reciprocal of cosecant is sine. The reciprocal of secant is cosine. The reciprocal of cotangent is tangent. Now likewise, I can also say the reciprocal of cosecant. If I needed to use cosecant, I could just say that that's 1 over sine. Now why is this useful? This is useful because we don't have cosecant on the calculator. But we can always put 1 over the sine of something because the sine is on the calculator. So I can use this. We just have to write it as a fraction. So if we're going to find the sine value ratio, we know that to be the reciprocal, since this is r and this is y. We need to write this as y over r, so then I rewrite this as 3 over 4. So the sine of this angle is 3 over 4. The same idea, we have to be a little bit careful with this one though, because if I write the sine of this, I get 5 over the square root of 8. You can't have a square root in the denominator, so that's a problem. So to fix that, I got to times by the square root of 8. And there's a little bit more that we can do with this. We get 5 square root 8 over 8. To go a little bit further, I can change this to 2 square root 2. So really I have 5 times 2 times the square root of 2, or 10 square root 2 over 8, which reduces to 5 square root 2 over 4. So that really is what my sine ratio fully reduces to. So now what I'm going to talk about, which we talked about in class already, are the sines. So you just have to be aware of that in quadrant 1 versus 2, there are certain functions that are positive. And in this, all functions are positive. This one, it's sine and cosecant. This one's tangent and cotangent. This one is cosine and secant. And here's why for sine and cosecant. If I draw any old thing, here's r, here's y. R, always positive, because it's a distance from a point to another point. Now, y, still a distance, but it is a vertical distance. And it's positive, so it's going up. So we have a ratio of y over r over y. That's a positive over a positive, which will always be positive. And the same logic will be true for any of these in this. Okay? General rules when finding a ratio to determine if what you have makes logical sense on paper. Sine can be anything between -1 and 1. Same as cosine. Those can both be between -1 and 1. And I'll get to the reason here in just a second. Tangent, cotangent can be anything. You can have tangent and cotangent be any ratio you want to be. Cosecant, whoops, excuse me. Cosecant and secant have to be smaller than -1 or have to be greater than 1. And it has to deal with how these ratios use the r, or the hypotenuse, because sine and cosine have x over r and y over r. And between these two things, we have to analyze and look at, this is always the largest of the three pieces. X is never going to be bigger than r. Y is never going to be bigger than r. So the biggest that it can be is that they're the same. So the biggest they can be is 1. Likewise, the smallest that it can be is -1, because this will never be bigger than that. When I use cosecant or secant, it's always r over y or r over x. Again, these are the largest, so we have to compare them as if they are the largest two things. So when we compare these, the smallest that it could be is 1 or -1. It's always going to be bigger, more extreme than those two numbers. So when you look at these, is these things possible? This one here is, this one here is, this one here is not.